Right. Hello everyone, my name is Vikas Kishwani. I am a final year student of Computer Science and Engineering. I am from Janmanga Institute of Technology and Sciences. My reference number is CT201516494426.
Hello everyone, I am Shrishti Jain. I am a final year student of Computer Science and Engineering. I am from Gyan Ganga Institute of Technology and Sciences, Jabalpur. My CT reference number is CT201516494431. Hello everyone, I am Shivangi Pathak. I am a final year student of Computer Science and Engineering. I am from Gyan Ganga Institute of Technology and Sciences. My city reference is CT2016187935.
Hello everyone, my name is Sumit Sahu. I am a final year student of Computer Science and Engineering. I am from Gyan Ganga Institute of Technology and Sciences, Jabalpur. My city reference ID is 2015160728. Thank you.
This is a short presentation by our team. This contest has brought the opportunity to propose ideas to develop various projects under several themes. Our project, Body Monitoring Twin, comes under the theme Smart Healthcare. The goal or objective of implementing this model is to assure how one can monitor the health of a person. Body Monitoring Twin allows to monitor patients in their own home or nursing. The proposal directly recommends changes for optimum health conditions. There are various parameters such as ECG, body temperature, pulse rate, etc. that can be used to monitor patients' health by the help of twin model from a remote location using cloud-based services and the twin technology. Let us begin with the flow description of our model. How the physical system is connected to its replica, that is the digital twin, how the twin will be simulated, and so on. The physical system that will be integrated with IoT technology consists of a wearable that embeds in itself 3 sensors. The data can be sent from any wearable cloth. We chose it to be a t-shirt. As mentioned, the t-shirt has 3 sensors, namely a pulse sensor, an ECG sensor, and a temperature sensor. The pulse sensor can be placed in any of the sleeves of the t-shirt and is used to measure the pulse rates. The ECG sensor is itself a configuration of 3 ECG electrodes along with a heart rate monitor. The temperature sensor can be placed under the armpit and is used to measure the human body temperature. All the data collected from these 3 sensors are sent to the Arduino that may or may not have a master unit. But ultimately, the data collected here would be sent to the cloud, which will further communicate with the twin. Let us proceed with the working of our digital twin. Before optimizing the digital twin, let us know what a digital twin is. The digital twin is basically a model representing a digital replica of some physical assets. Here, we can see a mathematical model that is expressing some values. How this mathematical model is generated is a matter of concern. A data set is required for processing and mathematical modeling. Some sort of ECG reports, body temperature and heart rate measurement reports are used to help in fetching and documentation of the data received from the sensors. Once this data has been reported, it can be used to predict changes. Several algorithms can be applied that enables changes in body parameters. There can be variations in our body parameters. Our body temperature can be low or high. Our heart rates or pulse rates can be too fast or too slow. There can be variations in ECG reports, or the human system can be in absolutely fine working conditions. Once these algorithms are applied to predict changes, they can be used for the knowledge of analytical changes. They can be used to calculate expected outcomes. Once the expected outcome is generated, a final decision is taken. The monitoring of patient's body through the sensors will be reflected in its twin. Any sort of issues and the state of human will be predicted here. In this way, the decision will be taken. How the physical system and the digital twin is connected to one another can be seen here. We can see a thin line or a mediator that is joining the physical system to the digital twin. This is nothing but the cloud based services. We can see the physical system is sending some data to the cloud is sending it to the digital twin is sending it back to the physical system as a response in the form of doctor's prescription. In this way, this cyclic procedure keeps going on and we will get the desired output. This is all about body monitoring twin and how it works as a whole system. The future scope is that all people are connected in the cloud and the cloud's data will be sent to all digital twins associated. The concept can explain how to establish communication between other agents such as a hospital. Yes, it can be expanded to a hospital as well. This was the basic brief description about the model. Now let us move to the topics that will be discussed.
Topics to be discussed are mathematical model of ECG, mathematical model of pulse rate, and mathematical model of body temperature sensor. And the final topic is the cost estimation. Let us begin with ECG. ECG configuration and equation. To begin with ECG modeling, we should know what type of configuration we are using in our physical system. The configuration used in a physical system is bipolar triangular configuration. In this configuration, two electrodes are applied on the arms respectively and two on legs. But the two electrodes on the arm create a virtual electrode on chest. That is why it is called bipolar triangular configuration. This configuration is vectorally represented by Ethenos triangle. The electrodes are represented as vectors so that we can use vector law of addition to calculate the different values generated by electrodes and plot the graph accurately. Mathematical equations used to calculate the resultant vector are to calculate the value of AVL, lead 1 minus lead 3 divided by 2, to calculate the value of minus AVR, lead 1 plus lead 2 divided by 2, to calculate the value of AVF, lead 2 plus lead 3 divided by 2. Now, by the help of these equations, we can plot normal versus abnormal graph for further comparison. Mathematical model. Here, we have used the mathematical formula to calculate ECG signal and have plotted a reference graph using MATLAB. Loading the function which contains calculation logic and using simple graph to plot the outcome. Plotting the outcome. Zooming in and here's the outcome. ECG simulation. By the help of MATLAB extension for Simulink and sensor hardware unit, we have created a simulation which can calculate ECG. Here, we are using Simulink library for Arduino support. We have created circuit diagram which exactly replicates the hardware unit. A filter is applied. Two extra algorithms are applied to filter raw ECG data These are LP filter and HP filter, which in turn generate filter DCG. These two blocks are used to display ECG and heart rate, but are commented for now. Now initiating the simulation. Here are the readings of ECG and heart rate, the difference between raw and filtered ECG, and heart rate separately.
To monitor pulse rate, we need to calculate some initial values which will be used to create a reference scale. The first initial value to be calculated is HRmax to calculate maximum heart rate. So the maximum heart rate formula HRmax would be 207 minus age into 0.7. So let us suppose the values of age to be 39, then HRmax comes out to be 180 bpm. After maximum heart rate, the second value to be calculated is resting heart rate, which is given by RHR average equals RHR1 plus RHR2 plus RHR3 by 3. So let us suppose the values of RHR1, 2 and 3 be 62, 65 and 63 respectively. Then RHR average comes out to be 63 bpm. The next value is heart rate reserve, which is HRR equals HRmax minus RHR. If we substitute the values of HRmax minus RHR from the above calculations, we get HRR value to be 117 bpm. After this, we have target minimum heart rate, whose formula is given by target HRmin equals HRR into 0.5 plus RHR. If we substitute the values of HRR and RHR from the above calculations, we can get target HR minimum to be 121.5 bpm. And then moderate target heart rate. So the target HR mod formula would be HRR into 0.7 plus RHR. If we substitute the values of HRR and RHR from the above calculations, we get target HR mod value to be 144.9 bpm. The last value to be calculated is intense target heart rate, which is given by target HR intense equals HRR into 0.85 plus RHR. So if we do the same and substitute the above values of HRR and RHR in this formula, we get HR intense value to be 162.45 bpm. And we can calculate beats per minute in 10 seconds simply by multiplying beats per 10 seconds into 6. By the help of above calculated values, we can make a reference scale which will be stored and be used for early predictions.
For temperature sensor, mathematical model and simulation, we again have used MATLAB. We had a temperature sensor in our hardware lab, so we used it and collected some real-time data. In this video, we can see that the read voltage function reads the voltage from input pin. Here are several readings for the read voltage function. Then volt to FA function is used. To convert voltage to Fahrenheit, this function contains two formulas. We can see these formulas from here. First, temperature in Celsius, which is equivalent to input voltage into 100 minus 50. Second, temperature in Fahrenheit, which is equal to temperature in Celsius into 1.8 plus 32. The answer is calculated after analyzing the mathematical equation. By the help of this mathematical equation, we can calculate the temperature of the human body. Here, no reference temperature is needed, since it is known that if the human body temperature rises above 98 degree, it is fever. The entities used in the model sum with the cost of rupees 3,672. The estimated cost will be rupees 4,000. This is all about our model, Body Monitoring Twin. Thank you.